Hey, Tony. Hey, John. Hey, Rajesh.
James.
Hey.
Hello, guys.
Hey, David.
Hello.
Tony, do you know if Satish is going to join us?
I think, Tony, your mic has a problem. Don't see the mic icon there. No, I don't think we cannot hear you, Tony. Yes, we started the meeting.
Oh, okay, here's Satish. Hi, Satish, do you hear us okay?
Hey, yes, I can hear you okay.
Can you hear me now?
Yeah, Tony.
Yeah, we can hear Tony, we can hear Satish. Good.
Okay.
Hey, there was some confusion about the meeting timing, and my key presenter doesn't have this meeting invite, but I can forward to him right now, I guess.
Yeah, if you could, that would be awesome.
Let me find out if he's available to join. And although our content is ready to share, I want to make sure there is quorum and good participation. So from some of our other EDA partners as well.
So Satish, this all CDX meetings are being recorded, and people can always go back and look up. I know a couple of people send me notes that they cannot make it for today, but I'm pretty sure they'll look up the recording.
So what is on the agenda today?
Yeah, what's the agenda, David?
The agenda for today was for Satish and team to present on the wide-eye format.
What format?
The wide-eye format that Intel has.
Chiplet interface definition format. But David, is it okay if we reschedule this? I want to give advance notice to some key participants that I would like to have here for the discussion.
Sure.
So
Like I said, the
we
content is ready, but I want to make sure that we have some folks. Recording is okay, but good discussion or having them be
Yeah.
a part of the conversation would be helpful.
Well, Satish, this is the standard CDX meeting. We do have the ADK meeting or PADK, whatever you want to call it, coming up in a couple of hours. Is that perhaps in a more
Do we have?
appropriate?
Yeah, that would be also okay. Do we have EDA participation there, like today?
Yes.
Okay, then that's okay. If you don't mind, just send a or whoever is running the meeting, if you could send out a email to.
Yeah, that's David.
Okay.
Yeah, the one which you include somebody specific in the invite that is not typically attending.
Well, yeah, so it's just Cadence. Synopsys has never joined these groups. Is there anybody from Synopsys that Satish that should be included?
Yeah, I mean, I can at least give them a heads up saying this is we're having this conversation. If
Okay.
they're not able to attend, that's okay. But I just want to give them
Yeah.
a chance to attend.
Okay, so you'll forward the invite to them.
Yes, I can. I don't have the 12 o'clock invite.
Okay,
So
let me
once I have it, I can share it.
let me add you to that. Okay. Okay, you should have received it right now.
Okay, thank you.
Okay, so we'll see you back in a couple hours then. I mean, you're welcome to stay on to this.
I'll see you guys at 12 again. Thank you.
Satish, what
Yeah.
we present again? Sorry, what kind of format is it? More like kind of like the standardization, like the spec for the die to die,
Die to package.
die to package.
We call it
What
the
is it?
chip and chiplet interface definition. Collateral.
Chip interface. Okay. Chip interface corrector
Chiplet interface definition.
definition. Got it.
Yeah.
This is that the same as the one that you shared last time. That like the for the assembly rules.
No, we haven't shared this in the past.
Okay.
Yeah.
Okay, that's good to know then. Yeah, I think we'll work the group now then.
Okay, cool. Thank you.
Okay, Satish. So yeah, we'll pick that topic up at
Thank you.
at 12 o'clock. Okay, then getting back to regular CDX business. Last week we didn't have a meeting, but we were able to meet with some of the folks face to face at the OCP Summit. What did you guys think of the OCP Summit?
Good participation. I think the audience was not necessarily a good target audience for what we were doing. But there was some good IP vendors. I think the demonstration center we had was good because a lot of the die-to-die interface vendors were there. We were chatting and collaborating with that. There was quite a few press people there and some ChipSACS folks there. But in terms of, there was over 4,500 people at the conference. The bulk of the papers and things were really outside of what we're looking at, much more like server infrastructures, a lot of cooling, sustainability. There was, it was a much broader area, and there was very little focus on chiplet-based stuff. I don't think there was any papers presented specifically related to chiplets. In our session, ODSA session, I think that was good. There were some good papers there. Morvell did a presentation jointly with Ilian, and there was some Bose stuff and UCI Express. But for the rest of the show, I'd say, most of us kind of know what we're doing anyhow with an OCP. but that's my take.
Yeah, I totally agree that the ODSA session was good. A lot of the work that has been done and it's ongoing was covered, and it was a nice. Actually, I was going to say it's a little forum, but actually it was a big forum, bigger than the Experience Center, but it gave opportunity to everybody from the Experience Center to share their mind and what they're thinking and what they're seeing, what they're expecting. So I thought that was a nice.
Yeah.
It went pretty nice. I think the Experience Center definitely a little bit of on the outside of the big show that Open Compute had, right? Kind of we are way on the other end doing real tiny stuff, but I think the Experience Center was a great idea.
Yes,
I'm
I
glad
agree.
that ASE has sponsored that, and we had the opportunity to showcase what we are doing, and everybody kind of got. I also felt that the Experience Center was all the presentations there were quite complimentary. Right, we had the die-to-die, we had ASE showcasing their packaging capability. We had the tools also. So I thought it went pretty. It was well rounded little Experience Center.
Yeah, but it was more kind of just internal, everybody looking at each other's stuff, really not much of a target audience that could really benefit from the demo. But I think that the concept would be good to do something like this at the Chiplet conference or some other conferences. It's probably too late to do much at Chiplet, although I did mention it to Lance, and he's thinking about maybe having provisions to do some demo type stuff.
Yeah, that would be great. Yeah, definitely the Chiplet conference is going to be the bigger Chiplet show.
Yeah, I would think so. I think.
Yeah,
I think I agree on that. I think like this is right. OCP they kind of mix between a lot like data center, like kind of like the server groups, like kind of like the concentration. I think like chiplet and semiconductor is a part of it. I think it's growing. I think that's great. I think like the chiplet summit will be more focused on the audience that is more on the semiconductor side rather than on the board and server side. So I think that will be more interesting to see.
Yeah, would be interesting to see. I agree, James. Kind of a combination. Probably over time we're going to get there, showing the system from chiplets to cooling, right? How probably once we get people talk about 130 by 130 millimeter substrates, it would be cool to see that with chiplets and how it gets cooled. I think that might be one point where the system design will kind of intersect.
Yeah, are you talking about more kind of at the predictive level, or actually integrating actual digital twins of actual cooling systems, like liquid cooled cold plates and that kind of stuff?
I think like maybe is meaning I think like they right since this chiplets I think like and the demands of this kind of processing power growing and a lot of this kind of like system are bringing inside the package more and more. So I think like some of this cooling will kind of like install at the server level. I think that they potentially will also bringing closer to the chip level as well. I think that might be interesting. Is that what you're thinking also, David? David, I think we lost you. Is your mic on?
Yeah, we don't hear you, David.
Yeah, we cannot hear you. We don't see his mic moving. Maybe there's like connection issues. Or Tony, you thinking something else on your mind on that cooling side? Or that's why I thought what he's saying. I think I thought the same thing too. There will be more bringing to the chip level rather than on the server side, right? I think they're talking about what we see there today. They were cooling on the server, like the rack around there, the piping. But I think that as the chip getting bigger and people are trying to bring everything closer inside the chip, right? So in that package, right, I think their cooling will bring to that level too, on the chip at the chip level.
Well, I mean, it was more a question of what David had in mind. What I was asking is, when we're doing all the predictive analysis and package design and thermal simulations. These are all simulations typically that are done kind of at the chiplet level, and we're really not including the actual TIM materials and heat sinks and liquid cooling and airflow. We typically have boundary conditions to model that. Now,
right.
My question was, should we, or we can. The question is, should we actually show maybe having an actual mechanical design with fans and airflow, or maybe liquid cooling and heat pipes, and have detailed mechanical models for those cooling systems in conjunction with the chiplets, because that is something that we could do. We'd have to bring in some different people to do that. Or do we just want to keep it more focused on the chiplet side and just assume that's done out by the other thing?
Right, I see where you're going. I think it's totally valid point. I think from my opinion, I think it's maybe a good point at least to touch point on it at some extent, right? Maybe not comprehensive, but I think definitely there is impact on it, right? On the overall kind of like the especially the thermal side, on the cooling side has an impact on it. And it's probably, I think it's good to at least I think I mentioned something around that point. Like may not have to get into the way in details like a lot read into it, but I think at least there's some like high level option there. What do you think?
Well, I think it's a yes or no. Either we have mechanical things in there or we don't, right? Because everything that we're doing now, we can do with kind of the tools that we have now in the demo. The question is, should we start introducing the mechanical design tools and some of the multi-physics, I call them sign-off thermal and warpage type of analysis tools. So if that's something we want to do, then I think we could talk about it on Friday when we do our demo call. I think that's probably where we should discuss this. Looks like David's having problems getting back in.
Yeah, that sounds good. Yeah, I think let's talk about. I think David, are you still? We can see your cursor moving, but we still cannot hear you. Are you? Can you trying to rejoin or something? No, we cannot hear you.
Let me call him.
Sure, we can call him. Let him know. Number.
We can't hear you. Okay.
Oh, you calling him?
Yeah, he's gonna quit and try to dial back in.
Yeah.
He was on, but
Yeah, I'll try and call him too. Yeah, that would be the best.
never had these problems with Teams, just saying.
Yeah, it could be everywhere. So Tony, you mentioned that there will be some demo you're going to do on this Friday, or which Friday are they?
No, the people that are working on the demo, we have a weekly meeting just to discuss the demo.
Okay, do you hear me now?
Now
I-
we hear you. Yeah.
Okay. What was the last you heard from me?
The,
There's a
When
long,
did I cut off?
Oh, it's been a long time, Dave.
the cooling
Okay.
you're talking about.
Oh, man. Okay.
yeah,
Okay.
you were
I'm glad.
suggesting, do we demonstrate cooling? And I wanted to know, were you talking about actually doing physical designs of heat sinks and cooling systems, liquid
okay.
cooled, mechanical pipes, or were you talking more
Yeah. So
more
I have
abstract
been.
level
Yeah.
modeling?
Yeah, I've been gone then for about 5 minutes. Man, I was wondering why nobody's saying anything. I was trying to fill the void.
No, this crowd is pretty vocal, so
Yeah. No, I was thinking that basically the convergence of design, to put it in better terms, right? That right now on one side everybody's thinking about big cold plates and just dissipating gazillions of power, and then on the chiplet side we're thinking about the small problem, right? The chiplet wear and tiny wires and all that stuff. But I do see there's a convergence around the system design coming maybe 5 years from now. Right, where the big cold plate guys are going to start thinking about where the chiplets are and what do they look like, and the chiplet guys are going to start thinking about that big cold plate and what impact it has on their life. Right,
Yeah,
kind of instead of modeling it as a big black box on the other side, kind of get a little bit more into the details of what's on the other side.
right. So you're saying basically, yes, you think we should start doing a little bit more of the mechanical modeling of the
Yeah.
actual systems. Okay.
Yeah.
Okay. So we do have tools and people that we can start introducing to the demo. I think we probably want to get a little bit further along. But you know, we've got those tools so we could actually do some mock-up designs.
Yeah, and probably that convergence, to be honest, I'm thinking it's probably going to be 5 years from now. But I think maybe a good idea to start that discussion.
No, it's going to happen much sooner than that.
Yeah. Okay. Good.
It's happening now with some of the government
Yeah.
systems. They are doing, you know, liquid cooling systems. The DARPA stuff, they're actually doing microfluids and stacked die. That's 5 years from now.
Yeah.
You know, the cold plates, you know, most of these big radar or high powered type systems, they're using cold plates now in mil-aero applications. All the servers are going that approach. Liquid cooling you saw a lot of that for the racks and stuff.
Yeah.
So that's here today. So I think, you know, I think agreeable, those guys, you know, they were all there and they, you know, none of them had any clue of what was inside the package. I mean, that was a black box. So I think having a demonstration where some of those folks could see how we need to work together and vice versa, you know, the chiplet designers having a better understanding of what kind of cooling systems are out there. Why not? Let's get it in there. I mean, we're talking about, you know, next OCP timeframe for, you know, the super demo, tying in some of the other stuff like the system stuff. So why not, you know, address as much as we can in these workflows. Now, we didn't actually have a mechanical section in our workflow document, and I think that's fine. But you know, maybe that's something we can do as our next white paper to start introducing how we start merging the thermal mechanical world with the electronic world, because they have been separate worlds, just like packaging and ICs were separate worlds, but now they're not. They're all munched together. And I see getting into the larger systems, you're going to see more integration between the physical thermal mechanical guys and these large systems that have lots of heat and the designers. It's not something you can, in the old days, you just did your chip design and you picked a package that had certain thermal coefficient, resistivity, and then you just left it as an exercise for the system designer to design the cool system to dissipate that heat. I think for these large systems, it needs to be part of the design process, not an afterthought.
Yeah, maybe that's actually a very good thought. Maybe that test case that we're thinking of doing for to exercise the workflow, right? We can still do that, but then consider instead of limiting it to a substrate with a few chips on it, consider how are we going to do this if we have 20 of those chips in a box somewhere in a rack, and how are we going to cool it, right? Every chip at 1,000 watts, and see what how that works.
Yeah, like an AI system would be a great application, but we can even use our arrayed processor. I think it's representative of an AI system where you put as many as those you can in a package, and then you put as many as those package on a board, and you put as many as boards as you can fit in a rack, and you fit as many racks as you can fit in the building.
Yeah.
There was a very interesting paper that I saw. I think it was Meta. They were talking about, the nirvana of the AI server world is to build a million server AI data center, and it's all interconnected with photonics, photo optics, and they estimated that it would take about 54. I think I remember that number, 54 gigawatts of power for that data center. So, and they said, oh, by the way, a nuclear power plant is good for about 5 gigawatts. So you're going to need 10 nuclear power centers to power this proverbial thing. So it's a big issue, and I'd say there was probably at least 10 to 20 demos where they actually had these big racks with cold plates, but a lot of them, I've never seen Exxon or Shell at an electronics show, but they were there showing liquid cooling where they're immersing the whole rack in cooling fluid, so the whole thing, and they're hydrocarbons, right, to dissipate that heat. And then, there's also kind of a huge effort that's going on in OCP is sustainability, right? Because, this is very ungreen. It's the new Bitcoin stigma of, heating up the planet with all this power. So they're doing all sorts of creative things. I think a company in Denmark is recycling that thermal energy to heat cities and stuff. So sustainability is a big deal. So I think getting involved in more of this thermal simulation kind of at the macro level would be interesting, because that's there's it's way beyond the stuff that we do day to day, but I think it is becoming a more important part of the problem. All power management, power dissipation, and everybody wants to do lower power, but kind of more has given up, and you're not getting more power in the advanced technology nodes. It's actually getting worse.
Yeah.
That'll be interesting.
Yeah, maybe what that's a good idea. Yeah, you're right. Seeing Exxon at the show was totally surprising.
Yeah, I said, what the heck are they doing here?
Yeah, I think that's part of the conversion too, right? I think that's going to happen here too, between the mechanical and electrical, between that chip interface.
and John, I know you and Lal have been involved in a lot of like high power kind of systems. We might be able to fold that into this as well.
Yeah, definitely.
So I think we can build on that thread.
Yeah.
So I think you know, I was you know, we scrambled to put this demo together, but I think it was very powerful. You know, I see the potential where people can actually see it and you can talk to it rather than just looking at a PowerPoint and say, yeah, that's
Right.
interesting. The fact that they can see it and things wiggling around and moving gives much more of an impression that it's real.
Yeah.
And
And
it's
spi-
getting real. It's not
Yeah.
real today, but it's getting real.
Yeah, you know, and spinning. Don't forget the spinning part.
The spinning part.
Oh.
You have to have the proverbial, you're not 3D unless you're spinning, right?
Exactly.
Yeah.
Yeah.
Maybe we could figure out, you know, get some AI and figure out how we can get that spinning to hypnotize people.
Um.
No,
Yeah.
just joking.
Yeah.
Yeah.
No, that's okay. I was going to continue your joke, but some other time. Yeah. You know, let me reach out to see who in OCP does this server and cooling part and see if there's anything we can work on.
Yeah, that would be good. Because we have some tools and we could, you know, work with them to, you know, put together a design. You know, we can kind of help with on the tool side, but
Yeah.
you know, we need the design expertise. I know it looks like he left, but Garrett is from AMD and that's the world that he lived in when he was at Intel, and he was kind of working on the tools when he was with Siemens. Now he's at AMD, so he can, you know, since he's participating in this, we can get him involved. He could probably even help on the put together
Yeah.
the demos, so I can reach out to him.
Yeah, I think that would be good. That would be good. Yeah. Let me capture a note here. And see how we can, what is there to collaborate on.
Yeah, that's always that's interesting. There are still some for what we need to compete, right? Right. David, on that, like those kind of like CDXML format and things like that. When
Yeah, the question there, yes. How do we, how do we bring that whole system thinking together, right? Because I'm not sure whether it's CDXML or something else at this point, or let's talk about it. But what is it that we need to do?
Well, JEP 30 does support board level and
Yeah,
maybe even system level. So if we have CDMXL, you know, we can get at least into the board and I don't know if it does anything beyond board. I don't know if it gets into racks and stuff, but you know, it does deal with connectors and stuff. So,
right. I need to see the board side, but I'm not sure on the rack side. Yeah, on the data center side, things like that. But at least there will be the closer one. Yeah, will be with the board side. I think that will be a good starting point.
right, because eventually it's going to go on a board, and that board goes in the rack, right? So
yeah.
So at least we can get into the you know, the board level or the rack level input piece
yeah,
and simulate that. And then, you know, we can build. I mean, when we have the mechanical tools and the multi-physics simulations, I don't even know if those guys are doing that. Probably not.
Yeah, yeah, it will be interesting to find out.
I'm also wondering if there is anything on the automotive side, because I recently saw a presentation that was talking about what kind of performance is going to be required from cars at their different autonomous driving levels.
Oh yeah, that's definitely one of the huge markets.
Right. And one of the things is that the autonomous driving, the performance it would require, it's bigger than some of the data centers today. So how is that going to happen? I don't know.
Yeah,
But
but you're
also,
not doing the learning. I mean, the data centers are really used to train the AI algorithms, but you're doing all the computing locally, all the sensor gathering and running, you know, the you're not doing the data learning. That's where the biggest
yeah.
compute center is. Yeah.
But even on the other on within the car, some estimate was putting the inference required at the performance required at somewhere at more than 1,000 tops. Right.
Yeah.
So that's a lot.
Yeah,
Yeah.
I think David, your point is I think like it's maybe it could be slightly different problems. I think like focus on the problem. I think like that is very concentration on the single or couple chip. I think on data center side it's more probably like concentration of the 100,000 of the chips, right? So I think I think from that standpoint, I think that yeah, you're right. I think that because inference, I think it's very critical, like a lot of real time, not as much on the data center for training, not as much in real time. I think that there's kind of different use case there. Yeah, but you're right. I think that in terms of concentration of the hits, yeah, definitely would be more on the inference side. I think on the single, I think that the autonomous driving on data center is not. They can be offset on more processors, so like more chips, they don't have to have that concern on the other hand. So, but they're more collective hit coming out all together.
Yeah. Maybe Tony, in your architect, the tool that Mark has that does performance analysis, would be interesting to see what the level 5 autonomous driving vehicle, how the performance of that would look like. I know it's going to look ridiculous right now, but kind of give people the idea. Here's the architecture and here's the problem, right?
No, we are those tools. We are working with the automotive vendors. Siemens is a German company. Mercedes is probably the market leader right now, and we have a whole program for doing digital modeling of a complete car system. So there's definitely a lot of opportunities there. That's not something we're going to do in the garage with 3 or 4 guys from the CDX. I mean, there's thousands of people working on that problem. But I think we can do some illustrative demos to, just kind of, focus on some of the early planning on the chip side, and then just, again, kind of the same thing we talked about is, having using some of the MBSC stuff to look at the model the software hardware partitioning, and then do some analysis of the system analysis to see how many processors you need, and so I think we can demonstrate pieces of that, and so define some big just processing problem, an automotive problem, a data center problem, and then have it kind of come up with how many processors, how many RISC-Vs it needs to solve that problem, and then we can go off and build the demo and do some predictive modeling.
Exactly.
I think what we have now kind of, we don't necessarily have to build an actual AI type of processor. I think what we have now makes the point without having to go off and build an autonomous car. which
Yeah. No,
yeah.
no, I didn't mean to build the whole autonomous car, but kind of hypothetical example of a few sensors and how much,
Right,
exactly what you were
right.
saying, right? How much compute power it's going to need, how much bandwidth, right? And all that
Right,
stuff. It
right,
kind of
yeah.
illustrate, hey, you're going to need 2000 terabits of link if you wanted
Right,
to convert
right.
in, right?
Right. And then, and that, we can map that into, X number of chips and putting them on a panel and, yeah, looking at the thermal of that. And yeah. Okay.
Yeah. So all the Mercedes cars in the future are going to be one big truck with servers and small nuclear reactor so that it can do the autonomous driving, it looks like.
Yeah. All right.
It's not going to be green at all. Yeah. Okay.
Yeah. Okay. So I started working on the white paper, and it looks like it's messed up. There's these diagrams that are on every page. Can you pull that up to see if you're seeing the same thing I saw?
Yeah. Okay.
Wait while David pulling this up, right? Oh,
It's already up.
okay.
Yeah, that diagram is like on every page.
Yes. Okay. Where I know why. Where do you want it to be? Where should it be? Let me see.
Zoom in. I'm having a hard time saying it. That's in my section, the architectural planning.
Okay.
Yeah, that's where it goes.
It needs to go where in here? So the thing is, this one. Okay.
At the end, so or somewhere. I think there's a diagram. It probably says where it is.
I think David, you push that in the header.
Yeah, I think that's where it belongs. Right. Well, yeah.
Okay.
Yeah. Is that what happened? It got pushed into the header.
Yeah,
it got pushed into the header. Yeah.
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 I mean, it's a good diagram, but we don't need to put it in the header.
No, you can. I think you can put it. We make it smaller, like the OCP logo.
So
okay, where do you want it to end up in this?
Well, just do a search for diagram. I think I said here's the diagram or.
Let me first of all drop it here. Okay, and then we'll find its place.
Okay.
Okay, that's where you want it to be. Okay.
Yeah.
All right. Oh, now I lost this. Okay, below. Okay, here we go. Yep.
You want to, while you're on it, you want to put that figure there?
Sorry, I don't understand.
Yeah. Okay. Okay.
Okay, you do have the figure there. Yeah.
Yeah, it also has a figure. Okay.
And you're going to compute the figure X?
Yes.
Okay.
And what's the question mark in? Is there something that you need there in front?
Just some text.
Yeah. Maybe
what is this?
You can put that, or you can assign Tony.
Okay.
I'll do like this.
Yeah. Yeah.
And I'll compute the access at the end.
Okay. So I started putting in, I have the inputs started and outputs for STA flow. Can you jump? I just want to make sure they made it in. I didn't finish, but at least they started. But
made it into the header or into the footer.
I put it at the end. I think most people put those at the end.
Yeah,
Yes.
it should be at the end.
Okay. Yeah, I see that. Okay.
Right. So I still have to finish that up.
Okay.
So I'll have
Perfect.
that done by certainly by next week, probably sooner.
Okay. I'll start cleaning up the rest of the white paper, any references, things like that. Also,
Yeah.
so
How are we
to
doing
have
on
it
the
done by next week.
rest of the actions? Are we getting there,
Yeah.
or do we need to
Yeah.
start pinging people?
Let me when I'm cleaning up this table, I'll review the actions and I'll ping people. So expect some spam and harassment from me about the
Okay.
white paper if there's anything missing.
Okay.
So since you've been warned, that's okay. And yeah, we'll clean it up and send it for publishing. Okay.
Do we have a conclusion or summary?
Yeah, we have abstract, right? I think that's something that
No, the conclusion needs to be done.
No. Okay.
yeah.
And probably the introduction, the
Yeah.
executive summary is also a little bit,
Yeah.
that needs to be
Yeah.
reviewed a little bit.
Let's get the guts written, and then once we know everything that's in there, your executive summary is summarizing everything that's in there, and
Yeah.
the summary just kind of, if we can get maybe everything in between firmed up and agreeable,
Yeah.
then we could do a final.
Yes. I'll ask ChatGPT to write the summary. See how good it is.
Not a bad idea for a starting point.
So David, can you go to the references at the end? I'm seeing there's references on top here, right? And then there are references go below there. Yeah. So I guess the first one, that one was that part of the test section? That references the outside there. So two references section now. We should combine them actually, right? Or remove one.
Yeah, we'll merge them. We have to merge them.
Yeah, probably I think this is more like the actual one, right? That one more like kind of, because that one doesn't have the number. That may be more like original template there. I think there's a kind
I'll
of
just add it.
Yeah.
Yeah, this is
Yeah, I added my references here. So
yeah, good. Yeah. Good. Yeah, we'll organize it.
that's the way you want, right? Not put the number, right?
Yes.
Just put the
Yep,
name.
perfect.
And you will put the
Yes.
number later on, right?
Yes.
You might want to remove that table though. Do we still need that table on top?
Yes, I'll keep it just for formatting. This is the template, just for to pick up the colors and things like that. Once I'm done with all the cleanup, I'll remove this table. But this has the nice coloring and text styling, right? I'll just copy it.
Oh, okay. For the template for other table usage.
Yes. Yep. This is not neat. Okay. Okay.
Things getting into more shape right now. That's good.
Yeah. And this will have to go in here. Okay, I'll add a footer for this as well. Where's the footer? Headers and footers. I'll organize it. Yep. Here we go. Now every page gets this yellow message. Okay, we're gonna use this license, Creative Commons. And this. Actually, I think this also needs to go in the footer. Oh no, turn it up. Let's see. Okay. Did it? This. Okay. And then about this. Oh, page 100. Okay, this is I'll say that this is to be removed.
We hit that finally.
Yeah.
What's that?
No surprise. Page hundreds. Page number hundreds. It's a
So
hundred
why
official.
why are we removing page 100?
No.
It would-
Just below all this line is just
Oh, you're
Old-
saying
just
everything
from-
below is going to be removed. Okay.
yeah because this
Gotcha.
is just from the template.
original, yeah, template.
Oh, so it just coincidentally happened to be at page 100.
Yeah. Yeah. Okay. All right.
So
Sounds
I'd like to order the leather bound cover of this.
okay.
Can we get the OCP to pay for all the authors to get a leather bound cover?
Um.
You want to put on your push shelf?
Yeah.
Yeah.
Yeah. This is definitely.
Then in the next conference, we can have copies there and sell them and autograph them.
Yes. Right.
Oh yeah, no,
would be
idea.
awesome.
Copy, right?
No, there was a guy at eSilicon, Basker. I don't know if you know him, but he wrote about a dozen books. He wrote the book on static timing analysis and synthesis and VHDL. He wrote a bunch of books. Didn't make a whole lot of money. There's not a huge market for.
Yeah, for some reason, yeah, book is kind of like after that digitize everything, it's not that kind of like money making anymore.
Yeah, if you can get universities using them, but even those, they've all gone online now.
Yeah, maybe have to make that as a movie, then that would maybe make more money that way. Turn that into a movie. And then Hollywood will buy the script and everything, so it might make some money.
Yeah, I guess you don't go to too many movies, huh, James?
All right, guys, we're drifting off here.
Yes.
When I was disconnected, I was saying last push on this paper. Let's get it done and send it for publishing.
All right. Do we have kind of a time frame where we need to get it into OCP to hit a window or something, or
If we
Is
are
it-
done next week, that would be perfect. That will give me time to present to all the different groups, and hopefully December we should be able to publish it for the new year.
all right? I'm not going to be able to put much time into this by next week. I'm traveling next week.
Okay.
Okay.
I'll have my SDA piece done, but
Okay.
Yeah, we can probably if we have it at 99% stage, I can go and present to the server group. And then
Okay.
by the time we get to the incubation
Yeah,
committee,
just let them know the guts are done. We're just, working on the summary
Yes,
and executive.
Yep.
Yeah. Okay.
exactly.
Yeah, meanwhile, maybe we can clean up a little bit on it, make it more readable, I think, that way.
Yeah.
And then we can brush up after, when you back, Tony.
Yeah.
Yeah.
Like I said, let's get the guts kind of finalized and all the tables and then I just plan on kind of reading it cover to cover and then kind of make sure everything is somewhat covered in the summaries and the intro. But I like your idea of chat GPT. Just as to kind of gather the thoughts. I probably don't want to use that literally, but we'll see what it does.
Yeah. I'll try it out, see. Do you know if it can read links, Google Docs links?
I don't know.
I'll ask it. I'll ask it and see. All right. Okay, guys.
So I think quick question, Tony, do you still have that Friday demo meeting going on, or I don't see that on your calendar?
Let's see. Are we meeting this Friday?
I don't see that this Friday.
Yeah, maybe
No,
extend it.
No, I guess we finished those up, right? So yeah, okay.
Start it
When
from
were-
next week.
When
Yeah.
were we do? When let's say next Friday. I'm going to be traveling.
Okay.
Maybe the week after then.
Let's see. The week after I'm traveling.
Wait, it's November time frame, Tony. Are you still actively traveling? I thought it should be starting to wind down.
It's actually heating up. It's getting worse.
Wow.
The
Until
16th is the next thing, but I don't necessarily need to be on it.
Yeah.
So I could set up the meeting and you guys should still meet just because I'm not
Yeah, let's
around.
do that. I think that's a good idea.
I've got trips coming up all the way out to December. Japan.
Oh, I see. On Asia side, that's why they are not starting that early. They don't have Thanksgiving.
Yeah.
All right, sounds good then.
Yeah,
Very
go ahead
good.
and set
All
it,
right.
Tony, and
Thanks,
we'll
guys.
see when we can meet. Yep.
All
All right. See you in about an hour.
All right.
I sent out that agenda thing. Yeah, we'll see you guys in a bit.
Yeah.
Yeah.
All right. Thanks, everyone.
Bye-bye.
Thank you.